Thank you very much, team, for sa pagsama sa akin dito sa ating 2023 MEFORUM. At I ask si Engr Jericho para i-present sa atin yung ating bagong electrical design standard, since most of our discussion for the month ng January will be on M&E standards. So siguro by next week si Vince naman yung mag-discuss ng sa controls, no? And may pinagawa ako sa kanyang control design for clean room na very useful para sa mga future projects natin, no? Yung project engagement natin dito sa Uni-tech. And today we'll ask to present si Engr Jericho para sa ating electrical design standards that we have been using actually for years already. So take it away, Sir Jericho.
Hello. Sir, rinig niyo ako, sir?
Yes, rinig na rinig.
Okay, alright. So, good morning. I'm Engr Jericho, and I'll be presenting our electrical design standard. Now, as much as possible, I want to wrap it up by 11:30, mainly because sobrang dami natin design standard since last year. Now, meron kasi mga changes kasi nangyari sa design natin, and eventually kami ni Sir Beng, we decided to improve our standards, especially when it comes to electrical. Now, in this case, I'll be explaining yung pinaka-basic ng electrical design and yung paano natin ginagawa sa Uni-tech. Now, sir, most probably sir, baka hindi ko matapos to by today. So baka next week ako ulit, sir. Kasi sa sobrang dami nating
Pwede tayo part 2.
Yes, sir. Dahil kasi sir, dami natin na improve since last year. So, ayun, I'll be explaining the fundamentals and the reasons why kailangan natin gawin ito. Yun pa. So, okay, next slide ko. Okay, now the design standards, our design standard will be divided into 4. Number 1, ang pinaka-important is the load schedule. The load schedule basically is the summary of your electrical system. Why? Kasi sa load schedule, dun yung makita yung panel boards, wire sizes, yung conduit sizes. When I say conduits, yung mga PVC, EMT, IMC, kung saan nyo ilalagay yung wire basically. And lastly, yung protection devices. When I say protection devices, hindi lang siya nagsa-stop sa breaker. Okay? Kasi in layman's term kasi sa electrical, alam lang ng mga tao is, when you say protection devices, breaker lang pinag-usapan. Unfortunately, hindi lang ganun yan. We're talking about relays, contactors, motor controls, etc. And lastly, number 4, the control system. Ito yung mga usage of BFDs, wide delta substarter, DOL, direct online, pag may mga jetpads tayo, etc. Now, for today, I will be concentrating on our load scale. Why? Kasi number 1, sobrang convoluted yung topic na to. And second, if you master load schedule, pwede ka na gumawa ng basic electrical plan. Like sa bahay or sa 2-story building, pwede na kayo gumawa. Now, sa load scale, marami tayong ma-deal when it comes to calculations. Because again, electrical engineering is more on the calculation side. So if you're gonna ask me, yung differences ng mga ginagawa namin dito sa Uni-tech versus sa previous job ko, the answer is halos pareho lang din. Naglo-load scale din ako, nagsi-schematic diagram ako, or also known as single line diagram, and then the layout. Now, for the layout, most probably baka next week ko na i-discuss yun. Mainly because sa sobrang daming i-discuss ko ngayon. So, yun. So, let's proceed. So, load scale is basically the summary of all electrical apparatus. When I say electrical apparatus, it involves all the motors, power, lighting, or the protection devices such as TBSS, kung may kita nyo na sa mga plano ganon, capacitor banks, or elevator, escalator, lahat ng pwede nyo ilagay that requires electricity, nandun siya. Now, in context of Uni-tech, magpo-focus lang tayo sa escalator, elevator, air conditioning. And of course, yung mga ventilation natin, mga jet fans, exhaust fans, etc. So includes the following: the circuit number, description of loads, the quantity of loads, power and volt amperes, current based on phasing. When I say phasing, we're talking about three-phase or single-phase that I will be further discussing later. Wires, cables, and conduit sizes, bus bar bracing, and protection device specifications. It is worth noting that load scale will be the basis of your panel boards. Why? Kasi if mapapansin ninyo ang ginagawa ko, it is very much important kung bakit ako humingi ng load scale. Why? Kasi whatever you place on the load scale will be translated into a panel board. So for example, may nakita kayong panel board sa bahay na 4 lang na branches. For example, may 50 ampere trip, 30 ampere trip, 20 or 10 ampere trip. Okay. Ibig sabihin, 4 lang yung nakalagay sa load scale niyo. Ganun lang siya ka-simple. Now, in our case in Uni-tech, load side lang tayo. When you say load side, meron tayong tinatawag na ECB or basically the enclosed circuit breakers. Okay, yung ECB na yon, if you're gonna ask any electrical practitioner, ang tawag kasi talaga nila doon is disconnection switch or disconnection breaker. Why? Kasi ginagamit lang yung ECB or disconnection breaker pag may maintenance tayo. Kasi obviously, you cannot do maintenance, PM, maintenance, or troubleshooting kapag energized for safety reasons din. So, next slide. Now, using the current projects that we have, yung Lapu-Lapu Uni-tech and the Uni-tech Alaminos, that will actually be the basis of this presentation. Now, as you can see, yung panel NBSGN, that is actually one of the load schedule of Uni-tech Lapu-Lapu. Now, pinapakita ko lang sa inyo to kung gaano ka-complicated na yung load scale natin from previous design standard. Why? Kasi number one, this is actually based on the Philippine Electrical Standard talaga in load schedule. Second, it's much more complete yung nakalagay dito. As you can see, everything is placed there. Yung circuit number on the left side, load description, kung ano yung load, kung motor siya, kung chiller siya, kung motor control center siya, kung pump siya, etc. The number of, etong CO, number of convenience outlet, nilagay ko lang dito kasi based siya sa standard na electrical. Pero, again, sa context ng Uni-tech, hindi naman natin kailangan. Pero, nilagay ko na lang din para if you want to explore this field, may idea din kayo. Ito number of CO, basically the number of convenience outlet, LO, lighting outlet, other loads, for example, mga aircon, mga elevator, escalator, etc. Now, as you can see, meron din volt ampere or basically power, the voltages, current, sizes of CV or circuit breakers, the ampere trip, frame, and pole, and then the sizes. Now, as you can see, ano yung nagbago from our previous standard from last year? We actually placed yung enclosure, type of enclosure, yung NEMA 3R, pag waterproof, pag sa labas, NEMA 3R, pag sa loob ng bahay, pwedeng NEMA 1 or NEMA 3. Now, case-to-case basis kasi siya kung saan natin gagamitin. Pero most of the time, when it comes to outdoor units, for example, chiller, or GMP6, GMP5, or yung outdoor unit sa mga split types natin, it is required for us to use NEMA 3R. Required siya. Okay? So, I will be further discussing each individual na nakasulat dito later. Pero as you can see, ganito siya ka-detail na ngayon from our previous design standard. Next, the content of load schedule, feeder destination, kung saan galing siyang previous panel board, load description, power, voltage, and current, protection devices, and then wires, cables, and conduit sizing. Now, the feeder destination, it is where the direction of the current fed from previous breaker. Now, like I said a while ago, lahat tayo ECB. May disconnection breaker tayo. Yung disconnection breaker na yan, nanggaling pa yan sa isang main breaker. Okay? Now, as you can see, meron ditong fed from. Ibig sabihin, papunta siya sa AC yung panel. Now, of course, HVAC company tayo. Hindi naman tayo electrical company to completely know kung saan nanggaling yung provision ng light side. Kaya for our simplicity and for the approval of para na rin magkaroon ng coordination between different trades, especially the electrical contractors, nilalagay na lang natin verify load scale. Why? Kasi para magkaroon tayo ng coordination, and second, to avoid any problems such as yung problema sa mga kite ratings, problema sa ampere trip ratings, which I will be further discussing later. Kasi based sa last year experiences namin nila surveying, marami experience. Meron kami na-experience na cases na ganun, na nagtitrip due to imbalances when it comes to tripping. So yun, simple illustration. Ang ECB natin, ito yung disconnection breaker natin na nakalagay sa labas, malapit sa outdoor unit. Meaning, ECB is fed from an ACU panel. When you say ACU panel, pwede siyang main panel, pwede any power panel na pinanggalingan ng source. Okay? It is important to determine as such in order to easily troubleshoot any currents of fault. Kasi, based on experiences lang, during my time here, sa mga susunod na projects din natin, kasi may napapansin kami na regular problem when it comes to electrical, and that is yung mga breakers natin hindi siya pare-parehong kite rating. Okay? When I say kite rating, it's kiloampere interrupting capacity. Normally kasi pag may ganyan, pag hindi parehong kite rating, hindi siya pwede magkaroon ng nuisance tripping na tinatawag nila. Now, yung nuisance tripping, I'll be discussing it later. Pero in this case, if you're gonna look at it, pinapakita ko lang na it is important to determine kung saan siya nag-fed. Kasi, pag hindi natin alam kung saan na nag-fed, mahirapan tayo when it comes to troubleshooting or quality control. Now, sige, ang pinakamadali example lang yung experiences namin ni Rap sa Sinocan. Meron kasi mga GMB5 na outdoor units na nagsusunugan yung board. Upon checking yung sa electrical, of course, yung ideal kasi nila, diagnostic kasi nila is may overcurrent siya and overvoltage scenarios. Ako, nung una kong chinek sa Sinocan, yung pinaka-problem kasi namin is hindi namin alam kung saan nag-fed. Why? Kasi ang sabi ng maintenance namin, hindi lang yung ECB or disconnection breaker yung nag-trip, kundi yung main din. So, trinace namin yun kung saan papunta yung ECB na yun. So, as a designer for electrical, it is important to place yung mga kung saan nag-fed from. para at least when it comes to troubleshooting, madali makita. So yun. Next slide. Load description, this is self-explanatory. Whatever you place on that circuitry, you actually place the load. Now, in this case, in circuit number 1, meron tayong 300 PR chiller. By the way, ito yung lalagay natin sa lapo-lapo. Yung new. Tapos yung 175, yun yung existing. Para lilipat lang namin yung circuitry. Pero, again, self-explanatory na lang to. Load description, whatever you place on that circuit, you place kung ano yung nilagay ninyo. Next, power voltage and current. Kasi many people are not really familiar between the three. Now, since chilled water tayo, I mean HVAC tayo, and we focus on BRF and chilled water, so it is best for me to illustrate in terms of chilled water terminologies. Now, ganito na lang isipin nyo. Kapag sinabi kong voltage, let us equate it sa pressure, sa mga GPN. Okay? Kasi ang voltage is actually considered to be the electric pressure. Pag mataas yung pressure, then the tendency is, di ba, sa tubig when pinag-usapan natin context ng chilled water. Correct me if I'm wrong, Sir Beng, this is just based on my understanding. Pag mataas yung pressure ng tubig sa isang pump, okay, or sa isang tubo, the tendency is mas mabilis yung flow. Possibility yan is pwede sumabog yung pipe mo or pwede magkaroon ng mga water hammer, etc. In this case, sa electrical, pag mataas kasi yung voltage mo, the tendency is there's a possibility na mataas yung current niyo or vice versa. In this case, para lang mag-gets yung simplest term nito, current is basically the flow of electrons. Or kung pwede natin i-translate yan sa chilled water, yun yung flow rate natin. So pag pinag-usapan niyo yung flow rate, kung mababa yung flow rate, sa electrical, pag-usapan natin yung current. Power is the rate of electrical energy converted into other forms. It is important to understand the power mainly because pag walang power, hindi rin naman nagagana yung mga motors natin, regardless if it's outdoor, escalator, elevator, etc. Now, lagi ko sinasabi to kay Vince na when you're doing load schedule, you need to take consideration yung volt ampere. Kasi when you use a catalog sa grid, or actually hindi lang naman sa catalog ng grid, when you buy any mechanical, yung mga motors na mechanical, bihira ka lang makita ng BA. Lahat kilowatts. Lahat nakawatt siya. For example, bibili ka ng motor, yung power input niya is rated at watts. Kasi yung watts na yan, na nakikita niyo sa mechanical description, it is actually based on mechanical power. Okay, yung mechanical power na yan, for example, pinakamadaling LSQ325, 109.9 kilowatt. It takes 109.9 kilowatts to operate mechanically. Kaya kailangan natin ng electrical ng 109.9 kilowatt para gumana. Now, ang hindi kasi alam ng most people, especially pag hindi ka na sa electrical field, meron tinatawag na reactive power. Now, reactive power happens when ito yung mga power alongside ng capacitors, inductors. Now, bakit ko ina-explain to? Why? Kasi sa chillers natin, sa GMBs natin, meron mga electronic components. Without it, hindi rin naman natin ma-operate yung power, yung mismong chiller natin. Kasi yung electronic side ng mga chillers natin, mga GMBs natin, sila rin yung nagpapa-operate sa compressor kasi sila yung nagbibigay ng communication signal. Now, that requires power. And most of the electronic components involve capacitors integrated circuits, transistors, etc. Yung mga na-mention ko, mga ICs, capacitors, inductors, it emits reactive power. Kaya dapat, when you're doing electrical works, you need to get the apparent power, or basically, yun yung combination between the real power, also known as watts, kilowatts, kung kilo yung pinag-usapan natin, and the reactive power. It's the combination of both. Okay? Kaya napapansin niyo sa mga load scale natin, lagi na naka-BA. Why? Kasi we need to take consideration yung mga maliliit na components ng reactive power. Okay. Now, bakit may beer dito? Kasi that's actually the point. Kasi when you drink beer, hindi nyo rin masyadong mainom yung foam. Yung mainom nyo lang naman is yung actual drink. Okay? Sa kuryente, or for example, sa mga Meralco or one, yung nakikita nyo yung nakasulat na watts doon, yun yung real power. Yun yung binabayaran natin. Yun yung consumption natin. Ang reactive power, ito yung mga power na hindi nyo nakikita talaga eh. Involuntary power. So, you don't really pay your reactive power per se, pero you need to take consideration in solving for current. Kasi, if hindi nyo na-consider yung reactive power, the tendency is pwedeng mag-undercurrent yung line nyo, or some cases, mag-under voltage yung system niyo. Pag nag-under voltage yung system niyo, baka magkaroon pa ng complications yung motor natin. Kaya, kino-convert natin sa apparent power. With that said, ang conversion ng volt ampere sa watts ay ganito lang. Hindi ko na masyado i-specify, pero it's based on trigonometry. Okay? Kasi ang basis kasi niyan is a right triangle. Now, the power factor is basically cosine. So, adjacent over hypotenuse. Kung gusto nyo balikan yung trigonometry. Now, for simplicity, guys, na-design namin ni Sir Beng alongside with consultation with Sir Edel sa baba. Pag chiller pinag-uusapan natin, yung power factor natin will be 0.8. Because, number one, aside from malaki yung chiller, it gives up a lot of current sa isang chiller. And you need to take consideration for that. Kaya, pag nag-divide ka kasi ng 0.8 sa isang number, syempre, mas tataas siya. So, mas mataas yung magiging wire sizes natin, tsaka yung breakers natin. So, you need to take consideration for that. Same goes with GMB. Kasi ang GMB, medyo mataas din yung power input na kailangan yan. Meron kasi tayo na experience sa GMB. Hindi ko na sasabihin kung saan yung lugar. Pero gawin nila natin 0.8 yung power factor niyan kasi para save din tayo. Pero for chilled water pump, based to sa experiences ko sa Rojas and based din to sa napansin ko, kasi naka 0.9 lang yung power factor natin. Kasi if you're gonna analyze this, if you're gonna divide any number with 0.8 versus 0.9, mas mataas yung 0.8 yung power factor. Why? Kasi ang chilled water pump, or in some cases condenser water pump, meron kasing number one soft starter tayong by means of wide delta and BFT. Ang purpose kasi nun, ng wide delta and BFT is to prevent inrush current. Okay? Yung power factor kasi, number one na goal niyan is, aside from converting from watts to BA, it actually takes consideration of the inrush current. Number two, yung starting current. Kasi, pag hindi nyo na consider yan, there are tendencies wherein yung kakasimula mo pala mag-start up sa motor, bigla na lang magti-trip. Ang tawag doon instantaneous tripping. And pag hindi nyo natin consider yung instantaneous tripping, syempre magti-trip siya. Worst case scenario, pwede masunog. So in this case, power factor is very much important for load scan. And madali lang naman siya technically. You're just gonna divide it by 0.8 or 0.9. Tapos as it is na yun. Next is for starters, if the system voltage is 400 or 380, the voltage is a line-to-line voltage with neutral provisions. Now, mapapansin ninyo when nagsasalita ako ng pag nagtatanong ako 380, 230, or 400, ganito laging tanong ko kung may neutral ba or wala. Kasi sometimes, depende kasi ito sa bigay ng Meralco or Paleco or Beneco or whatever electric cooperative. Kung 400 or 380 yan, most probably may neutral provision yan. Okay. If the voltage is 230, then it's a line to neutral configuration. Yung experiences ko nung dating kong work, pag sinabi kong 230, pwede naman siya maging single phase, pwede rin siya maging three phase. In the case of Cebu Electric Cooperative, 233 phase siya. Dito sa Metro Manila, meron naman 230 na three phase, meron din 230 na single phase, depending on the geographical provision. Now, in the case of chillers and GMBs, napapansin ninyo, naka 380 or 400 siya. Okay? Why? Kasi number one, there's involvement of electronics involved. Bakit? Bakit ko sinabi yun? Kasi if you're in the case of 400 or 380 at meron kang electronics involvement, based on what I know, most of the electronic devices will only operate at 230 volts. Paano mo makuha yung 230 volts? Pag line to neutral. Okay? So, ibig sabihin, itong 400 na to, line to line. Pag ginawa niyo yung line to neutral, 230. Kaya nagkakaroon ka ng neutral wire. Okay? For the basis of number one, protection of overcurrent. And second is yung para magkaroon ng provision or ng supply yung mga electronic components sa loob for chillers and GMBs. Okay? So in some cases, 230 volts can be line to line. Yun nga sinabi ko kanina dun sa Cebu. Ganun na itsura. Kaya nga, ang system voltage dun sa Lapu-Lapu is 230, not 380. So next, calculation. Actually, halos lahat naman sa inyo marunong na kasi tinuruan ko lang mag-calculate. So KB, pag single phase, KVA over B times 1,000 kasi nga naka-kilovolts eh. Okay, applicable na naman ang kilovolts kasi gamit natin chiller. Pero kung nga gamit lang natin mga split type, for example, 2 HP, ganun. Same lang naman din. BA over B lang naman siya. Now, pag 3 phase, dito na pumapasok yung factor of square root of 3. Okay? Saan galing ang square root of 3? Basically, cosine 30 degrees. Okay? Or basically, the arc cosine of 0.8. Yun eh. Yung kPa times 1,000 over square root of 3 times B, yan yung ginagamit ko when you're doing load scan. Yun ang pinaka-standard eh, line to line. Always assume na line to line yung basis natin kasi number one, mas mataas kasing bigayan ng ampere ang line to line versus line to neutral. Why? By mathematics lang naman eh. If you're gonna look at the denominator, mas mababa versus sa line to neutral eh. So, ibig sabihin, pag mas mababa yung divisor mo, syempre, yung quotient mo ay mas mataas. In this case, Pag mataas yung basis mo ng line to line, di mataas din yung basis mo for protection device. Ibig sabihin, mas ano siya, the possibility of being safe or reliable is higher than the calculations for line to neutral. Kaya ang nakasanayan na rin by practitioners and by ako dito rin sa Uni-tech is line-to-line calculation. Okay, so pag 3-phase ng supply natin, ganito yung ginagamit natin, yung second formula. So again, going back here sa Lapu-Lapu NBSGN, as you can see, I converted itong 300 PR sa volt amperes. Basically, it's 216 kVA. Ganun kalaki siya. Now, paano ko nakuha yung 3-phase? It's basically 216.5 kVA times 1,000 kasi nga kVA divided by 230 times square root of 3. Ito makukuha ninyo. 543.46. Now, hindi ko kaya ma-calculate dito kasi wala kasing calculator. Pero if you want to try it, madali lang naman siya. Okay. Next slide. Ito naman yung sa Alaminos. Now, sa Alaminos medyo madali lang naman siya when it comes to electrical, mainly because maliit lang naman siya, hindi naman siya chiller. We're doing split type eh. So in this case, ito yung equipment sked na ginamit sa unit of Alaminos. As you can see, it's 15.5 kilowatt. Dinivide ko siya ng power factor ng 0.8, kaya naging 19,375 volt ampere. Now, in this case, using my regular calculation, 19,375 divided by 380 times square root of 3, you're gonna get the quotient of 29.45 amperes. Ganun lang naman siya kasimple. Straightforward, pero worthy. Okay? So, in this case, siguro nagkakaroon na kayo ng idea, pag electrical, paulit-ulit lang yung ginagawa namin ng calculation. Ganun lang kasimple siya. Pero, you have to consider din yung mga safety factors and continuous load. Next slide. Okay. Protection devices, ampere trip and ampere frame. I'll be discussing this in a layman's term para mas madali nyo intindihan. Ampere trip, the one that you can see on the left, nakita nyo, this is actually a 15 ampere trip. Okay? It is the amount of current that will trip. When you say tripping, ayun yung the amount of current, the maximum current that will not, hindi siya possible na masusunog, pero para siyang may safety factor. Okay? Or in this case, the 80% of the capacity of a breaker. The ampere frame, on the other hand, it is a rating breaker current, maximum current, which the breaker will withstand for a long time. So, ampere frame basically is, pag lumagpas kayo sa ampere frame, sunog na talaga yung breaker ninyo. Yun yung definition niya. So in this case, this is just the code reference based on the PEC. Okay? Now, nilagay ko lang dyan for, kasi remember, what I'm saying is based on minimum standards of the Philippine Electrical Code. So I place references here para hindi naman tayo parang mangunguna din. So in this case, ito yung actually, kinuha ko lang to sa net pero upon checking sa PEC kanina, pareho din naman siya. So nag-conform naman. So in this case, ito yung standard ampere ratings. When you say standard ampere ratings, these are actually the theoretical ampere trips. Theoretical, hindi yung actual sa field. Kasi sa actual sa field, meron pa nga 6 ampere trip breaker, may 23, may 63. Hindi siya pare-pareho. Okay? Pero when it comes to the standard sizes, based on PEC, ito siya. Okay? 15, 20, 25, 30, etc. Now, per plants, based on City Hall standards, sa aircon, ang pinakamaliit is 30 dapat. 30 dapat talaga. Based on Philippine Electrical Code. Pero kasi, since meron naman tayong catalog, we know kung ano talaga yung power input niyan, then nagiging allowable na rin ang 20 in some cases. Okay? Kasi based lang siya sa based lang siya sa computation. And second, mga FCUs natin saka ACCUs, yung maganda sa grid is hindi naman siya ganun kalakas sa kuryente, especially the inverter type. So in this case, yung pwede tayo gumamit ng 20 ampere trip kasi number one, we're confident on our solution, and second is nandun naman sa catalog ng grid, and naka-ano naman yan, nag-undergo naman yun ng testing to prove its legitimacy. So again, ito yung basis ng ampere trips. Okay. Yun. Next. So in this case, for ampere trips, ito example sa big dock. As you can see, I use 80 ampere trip. Okay. Why? Kasi for ampere trips, there shall be a safety factor. Kasi again, a while ago, like I said, most motors do have starting current or inrush current. By definition kasi niyan, starting current is 10 times the original current. Okay? Kaya nagkakaroon ng multiplier ng 2.5. Now, saan galing tong 2.5? Saan galing tong 1.75? It is actually still based on the PEC. Page 362 ata or something. Pero ilalagay ko na lang dito sa PowerPoint after this MEFORUM para may reference tayo. Pero nasa ano yan? Nasa PEC siya. Ang minimum na safety factor ng ampere trip is 1.75. Okay. Pero for the sake of being reliable and safe, gumamit tayo 2.5. Now, for MCC, napansin ninyo, nilagay ko na lang is 1.75. Why? Kasi number one, may Y delta starter tayo. May BFD din tayo. Standard na kasi natin magkaroon ng Y delta starter bypass with BFD. Yung dalawang components na sinabi ko, it actually prevents yung starting current and inrush current. So if I'm gonna place 2.5 pa sa multiplier ng MCC, then the possibility of overkill might happen. Or hindi naman overkill, pero yung over-design might happen. Kaya it is safe na, ito rin yung basic experiences ko sa ROHS. Ang ginamit kong factor is 2.5. So yung wire size ko is 30 mm squared THHN. Yung sa bandang dulo, hindi nagkasya yung 30 mm squared THHN sa terminal block ng motor. Masyadong makapal. So, binawasan ko talaga. Nung tinry ko yung 1.75, yung ginamit kong size is 8.0 lang. And saktong-sakto dun sa calculations ko and sakto din dun sa motor ko. So, yun, nagkasya naman siya and nung nag-operate hindi naman siya nag-trip at hindi rin na siya nasunog. Mainly because, dahil nga number one, may bypass tayo. May Y delta bypass tayo. So, again, 1.75 is the safest for MCC. Pero when it comes to ACCU or chiller, mga LSQ 3 to 5, mas malala pa nga pag water cooled, 2.5 shall be our safety factor. Okay? So ito, size of CB, nakikita sa lower left, 80 AFP, 80 ampere trip, so 80, AF is 100, and P is pole. Pole is 3, okay, kasi 3 phase. Now, speaking of pole is actually, it is a terminal of wirings. Sa pole kasi, dyan idadaan yung wires ninyo papuntang breaker. Now, as you can see on the left picture, may isa ka breaker dito. This is actually a two-pole. Two-pole. Gumagamit tayo ng two-pole pag single phase. Take note of that. Pag single phase yung system nyo, two-pole. So, in this case, pag FCU, mas maganda gumamit ng two-pole. Sometimes we do one pole kasi line to neutral. Pag line to neutral kasi yung system ninyo, single pole ang gagamitin ninyo. Pero pag hindi siya line to neutral, line to line 230 volts, two pole ang gagamitin ninyo. Okay? Now, pag three pole, which lagi naman natin ginagamit kasi most of our motors are three phase, kaya three pole ang gagamitin natin. Why three pole? Kasi may line 1, line 2, line 3. Pag two pole, line 1, line 2 lang yung i-consider mo. Pag single pole, ibig sabihin line 1, neutral yung gamit ninyo. So, yun ang difference. Okay? One pole equates to one line, basically. So, next. So, if it's three phase, then the pole is 3P. If it's single phase, then the pole is 2P. Kasi line 1, line 2 lang yung given mo. If the source is line to neutral, then use 1P. Merong case kasi wherein napilitan tayo gumamit ng 1P. And that is during the construction of Arton. Okay? Yung sa panel boards kasi natin, gumamit tayo ng one pole. Kasi ang given provision kasi ng Arton, di ako sure dun sa usapan, pero it's 230 line to neutral. So pag sinabi sa ng tenant at 230 line to neutral yung provision, then line to neutral obviously yung basis ng calculation ninyo. Then the pole is 1P. Ganun yung gamit ng poles. Next is ito. It is actually a sample panel board. As you can see, ito yung mga bus bar niya, yung grounding bar, may neutral bar. In wire sizing kasi important yung neutral at ground. Okay? So, sa tayo gumagamit ng neutral, again, sa sinabi ko kanina, GMB tsaka sa chiller. Sa ground, importante yung ground kasi yun yung protection nyo from lighting. Okay, next slide. So wires and cables. Now, wires and cables depending on the size of the ampacity. Kasi for example, you have 40 amperes yung current niyo. Then, may corresponding wire size na dapat piliin ninyo. Now, in this case, wire sizes are anything below 30 square mm HN. So, pag sinabi kong 22, 14, 8, those are considered to be wires. Pero pag sinabi kong 38, 50, 125, 100, hindi na siya wire technically. But you actually call it a cable. Yun ang basic definition. Now, meron naman kayong copy dito sa office. Marami tayong copy nito. Pinapotocopy ni Paolo at ako. This is actually the basis of wire sizing. Sa Uni-tech, sa GRI, we use THHN or the thermoplastic high heat nylon coated wire or THHN. Pag electronics, on the other hand, we use 2.0 or in some cases, TF wire. TF. Okay, wala dito yung TF. Pero pag communication, normally pwede tayo gumamit ng 2.0. Now, as you can see, yung on the left side, merong sizes. 2.0, 3.5, 5.5, 8.0, etc. Those are the sizes in metric. Now, sometimes, pag mag-uusap kayo ng electrician, hindi nila alam yung metric. Okay. Pag sinabi kong 14, isip nila ay 2.0. Pag sinabi kong 12, isip nila is 3.5. 8, 8 pa rin yun. Okay. Ang sinasabi kong numbers, it is actually AWG. Yun yung alam ng nasa field ng mga electricians. AWG AWG system, also known as American wire gauge. In this case, going back sa illustration ng sinabi ko, for example, may 40 ampere trip ka, ay may 40 amperes ka. So, if you're gonna check my cursor, 40 amperes is between 5.5 and 8.0. Okay, ito PHs yan tayo So in this case, you don't use exactly kung ano yung nakasulat dito. Pag sinabi kong 40, we cannot use 5.5 kasi sumakto siya So you use the higher size. So therefore, 8.0 siya. So in layman's term, kung ano yung mga nakasulat dito numbers, wag nyo sagarin. Okay? So for example, nakuha ka ng 50 ampere trip. 50 is between 40 and 55 dito sa 90 degrees. So you use 8.0. Okay? Para maging safe tayo. Now, meron mga tinatawag na diversity factor, safety factor, etc. Pero I will not be discussing it anymore. Pero just to be safe, kunin nyo lang yung one size higher. Pag ganun, umabot kayo sa alanganin na current. Okay? Ganun lang naman siya ka-simple. Now, so in this case, okay, sa big duct, hindi ka pa to revise kasi the neutral wire size must be at least 50% of the line. Okay, kapag, ganito na lang explanation yan. Kapag ang size mo ay 22, kunin nyo na lang yung kalahating size niyan. Okay, wala naman 11 na wala naman na 11 mm squared So, kinuha ko na yung next list, which is 8.0. Now, possible siya sa code? The answer is yes. Neutral wire size must be at least 50% of the line wire. Okay, now, yung purpose kasi ng neutral is, aside from mapagana yung mga electronics involved, yung second kasi niyan is to prevent overcurrent. Kasi ang neutral wire, doon pumupunta yung overcurrent. Doon siya pupunta by virtue of Kirchhoff's law. So in this case, hindi ko na na-explain Kirchhoff's law kasi physics yun. Pero yun ang definition niya talaga. So if 3-phase, the wire shall be 3-1 format. Okay? Tatlong wire, isang ground. 3 hot wires, line 1, line 2, line 3. If it's neutral, 3-1-1. Gumagamit tayo ng neutral again for GMB and chiller. Okay? Kaya nga sa LSQ 325 gamit natin is 125 square mm squared at 30 mm squared KHN for neutral and ground. Pag single phase, 2-1 lang siya. 2-1 lang siya. Next, wire selection. Normally, the size of wires will depend on the next ampacity. Yun ang sinasabi ko kanina. Pag alanganin based sa table ng PEC, gunin nyo na yung next higher ampacity or higher size. However, the cables, the easiest way to get the wire size shall be based on the ampere trip. Okay, ito, tingnan nyo. Dito sa LBSGN, yung 300 TR, di ba 543 yung current nyo? Wala naman, di naman umabot ng 500 yung wires natin So the tendency is, dagdagan nyo pa ng isang kable, ng isang wire. Okay? Ngayon, tingnan na lang natin din sa MCC para mas madaling explanation. 395. Okay? Ang wires na ginamit is 150 at 30. Ngayon, ano ba yung 150? 150. Wait lang. 150. Hindi na kaya. Hindi na bumabalik. Ayun. Ang 150 is just 295. 295. Itong hina-highlight ko, 295. Okay. Ano yung current dito? 395. So, lumagpas siya. And based sa table, hindi naman walang table na umabot ng 395 or 400. So, ang tendency is, pwede tayo dumoble ng kable para umabot siya ng 395. Okay, pwede yun. Allowable yun sa pag cables na. Pag wires, pwede pa rin. Okay? Kasi you're doing raceways, wireways, kasi number one, value engineering. Kasi remember, the higher the larger the wire, mas mahal per meter. Okay? So in this case, mas mura pag dinodoble nyo na lang yung lower size para makatipid. Second is, syempre, yung pangalawang reason is, masuffice yung current requirement. Okay. Next, conduit selection. Mabilis lang to, pero ang gamit lang natin sa Uni-tech is PVC, IMC, and liquid type. Hindi tayo nag-EMT for the purpose of madali masira at madali siya makalawang. Pero for the sake of value engineering, sometimes we use it, pero ideally we discourage it. We discourage using it. Okay, most of the time IMC and liquid type kasi they're galvanized steel and hindi siya nakakalawang basta-basta. Okay, so ito yung table. Ito na nakita ko mabilisan na chart na malaki. So ito na nilagay ko. I'm sorry. Naka-EMT pa pero as you can see, as the sizes of the conduit increases, the number of wires, possible wires na pwede mo ipasok increases as well. Okay. Next, kite rating. Kite rating is very much important sa choosing a breaker, mainly because to avoid nuisance tripping. Now, in the case of Sinokan, there's a possibility na may nuisance tripping. Nuisance tripping happens during overcurrent, okay, or under voltage. Okay. Another example na experience ko nuisance tripping is dito sa Uni-tech. Ay, dito sa building mismo, sa R1. If you recall, meron isang instance wherein lahat ng motors natin gumiba. Okay. Yun ang example of nuisance tripping. Hindi naman kasalanan natin kung pag-uusapan natin kung sino accountable. Hindi rin kasalanan ng electrical. It just so happen na meron tendency na possible na mangyari yung nuisance tripping. How do you prevent nuisance tripping? Number one is to coordinate with the electrical contractors kung ano talaga nilagay nilang kite ratings. Kung pangit, ay kung 14 kite rating nilagay nila, use 14 kite rating dapat. For standard CHP kite, it must be 25 and the chiller must be 36. Kasi it is very much important na dapat pareho yung kite nyo. Kasi when it comes to short circuit analysis, pag mataas yung kite ng ECB versus sa main, hindi yung ECB yung magtitrip, kundi yung main yung magtitrip. That so happen nangyari yan dito sa R1. Hindi nag-trip lahat ng mga MCC natin. Hindi nag-trip yung Y delta natin, hindi nag-trip yung provisional breaker ng side ng electrical. Pero yung pinaka-main ng chill water pump yung nasira. So, ay nag-trip. So, kailangan natin magkaroon ng coordination for that. Okay? We need to take consideration in choosing a breaker. Hindi lang tayo basta-basta pwede bumili ng breaker dahil lang mura or dahil lang na-calculate natin na 50 ampere trip yan. You need to take consideration now yung kite rating. Kasi hindi naman siya masyadong pansin sa una pa nagka-problema. Pero pag umabot tayo sa problemang yun, medyo nakainis na i-troubleshoot. So yun sir. Yun muna sir, yung presentation ko. And yun sir, kung okay lang sir na Next week na lang sir yung single line sir.
Oh, okay, Jericho. Sige, siguro may mga question lang ako, Je.
Sige sir.
When yung describe mo yung apparent power, when is apparent power useful on field application?
Sir, pag generator sir. Generators. Kasi sir, for example, dun sa ROAS, gamitin ko na yung practical example. Wala pa tayong permanent power nun. So, ang ginawa ni Sir Edel is, kinalculate niya sir yung KVA ng mga chillers natin versus sa given provisional generator natin. Ang generator na gamit natin is 200 kVA. And yung dun sa generator is 109.93 to 109.9 kilowatt. So, ang ginawa niya, gumamit siya ng 2 chiller tapos isang pump para magkasya. Gano'n yung ginamit yun. So, by practice, yun ang kinitake consideration niya para gumana sir.
Pero doon, nung pinagana niya yun, yung lighting inside mall, 100% din.
Ay sir, ibang generator naman sir yung ginamit niya.
Okay. Magkaiba.
Yes sir. Kina-calculate kasi yun sir. Yung basic niya.
Another question na naisip ko is yung given yung simplicity ng HVAC load for typical unit of mall, will the PEC require yung extensiveness ng short circuit analysis?
Actually, sir, ngayon, sa base ng mga troubleshooting ng ginagawa ko, kailangan natin siguro magkaroon ng idea na we need to take consideration na. Kasi sir, dito sa Sinopan, sir, maayos ang meter namin, maayos yung wire sizes namin, nag-continue test kami sa mga boards, pero baka nasasunog yung mga boards. So, and ang masaklap pa dun, sir, isang unit lang, sir, hindi yung ibang units din. Parang isolated case siya. So, most probably, sir, baka we need to take consideration na yung pag-design nun. Kasi sabi ko kanina, sir, sinabi ko na sa electrician na baka yung breaker yung problema. Kasi, bakit kung may problema yung sa motor natin, sa GMB, bakit hindi nag-trip yung sa atin? Bakit dumiretso sa main?
Okay.
So yun, sabi ko, baka naging nuisance tripping na to, nagsisimula na. And based din dun sa facility, yung maintenance nila, sabi nila sa akin, nag-overcurrent, ay nag-over voltage. So baka, yun na nga, baka nagsisimula na nga yung cause of nuisance tripping. Kaya sumakto na rin din during this presentation, nasabi ko na rin. Kasi when it comes to design, we need to simulan na natin take consideration nun, sir.
Okay. So meaning yung simplicity ng design natin still merits yung short circuit analysis. Kasi kung like yung example mo kanina, like RR1, no? Hindi naman natin gusto magkaroon ng nuisance tripping pero still na-experience ng building.
Yes, sir. Yes, sir.
Then, one last question, Jay, is yung ano yung mga safety testing measures na dapat i-conduct prior to operation ng chiller, cooling tower, pumps?
Walang laman, sir. Hindi pa ako
sir.
Wala nga, sir. Hindi pa ako
Sir, yung when it comes to maintenance, sir, number 1, continuity and meter test. Yun talaga, number 1. Yun yung 1 and 2 yun sa electrical. Kasi we need to take consideration yung installation ng wire. Kung may sugat siya or kung may shorted. Second is, pag nagsa-startup, sir, dapat more than 3 hours in checking natin. Kasi in Philippine Electrical Code, sir, may tinatawag na continuous load. Ang continuous load kasi, sir, more than 3 hours yung gawa. Pag between that time frame walang nangyari electrical problems, then nasa steady state na siya. Meaning, okay yung maayos yung pagkagawa. Pero pag within that 3 hours, nagka-problema, nagsimula mag-trip, nagsimula mag-arcing, then we need to take measures na, sir. Yes, sir.
Okay. Yung naisip ko kasi doon sa case ng unit of Lapu-Lapu na we will about to start din yung project na yun. Since meron tayong transformer doon na ilalagay, so may mga i-conduct din tayong testing for the transformer, no?
Yes po, high potential test.
Okay. So yun dapat pala i-consider natin. Papakonduct din natin with the supplier ba yun? O tayo na?
Actually, sir, usapan namin, Sir Manuel. Sabi ko, Sir Manuel, kailangan ko puntahan, sir, kasama ng isang witness.
Oo.
Tapos, sir, high potential test tayo, sir.
Tama. Okay.
Yes, sir.
So guys, baka may mga tanong pa kayo kay Engineer Jericho. Baka si Alvin, si Jeffrey, baka may tanong.
Wala po, sir. Clear po sa akin.
So yung as-built mo, ipipresent mo pa bago ka umalis, no? Pero gusto nating gawin yung yung sequence ng M&E standards na yan for the month. Most likely, masunod-sunod natin and then mabalikan natin tong electrical standards na na-present ni Sir Jericho para matapos natin yung isang buong portion ng electrical design standards na we are actually implementing sa Uni-tech. Para alam nila, align tayo lahat. From mechanical, align tayo sa international standards. Sa electrical, align din tayo sa international standards. So yun guys, baka may tanong. Si Vince, may tanong. Si Ella.
Sir, si Ella nandito, sir. Ella!
Yun
lang punta dito, sir.
Ella, ito na.
ba't di kayo mag-open ng video?
Hindi, sir. Nag-CRP ka, sir.
Okay.
Yes, sir.
Yan. Si Patrick, baka may question.
Ito, question po lang. Ito, sir, si Ella.
Ayun, sir. May Ella.
Oo. Pwede naman magtanong.
Wala daw, sir, eh. Wala daw siyang question.
Nakakamusta lang din.
Nagutom na.
Gutom na, sir, eh. Gutom na, sir.
So, yun guys. Maraming salamat. And sa mga susunod nating MEFORUM, pag-usapan natin yung mga incentive ng mga nagpe-present para ganahan. No? So, natutuwa ako kasi sinasamahan niyo ako dito. Mabuo natin itong design standards na ginagawa natin for Uni-tech, and I hope magagamit ka rin ito. At pwede niyong balikan itong mga ginagawa natin na ito kasi i-upload ko naman ito sa YouTube para mapanood niyo. And then, yung mga susunod na engineers, mapanood.
Yes,
Okay guys, siguro mag-photo tayo para meron tayong remembrance dito para kay Sir Jericho dahil nakasama natin yan. No. So 2023 na guys, i-focus nyo lang yung sarili nyo. Gawin natin ito ng maayos. Lahat ng ating magiging sistema dito with Uni-tech, sigurado. Madadala nyo yan kahit nasaan na kayong. And I hope gawin nyo itong venue na to, itong MEFORUM natin para maging matuto kayo, maging blessing kayo sa iba. Yan. Okay, so picture muna tayo. Photo session muna tayo. Yan, ready? 1, 2. Yun, no? Nawala si Pleto Barkada. Okay guys, maraming salamat sa inyo. And
thank you po.
Pag-usapan natin
Thank you, sir.
ang topic natin. Thank you. God bless sa inyo lahat.
God bless, sir.
Happy lunch.
Thank you, sir. Sa inyo rin.